So suppose we have an infinitely nested square root expression like square root of 2 plus square root of 2 plus square root of 2 plus square root of 2 and so on. This pattern continues on infinitely, and there are an infinite number of square roots. How can we find the value of such an expression? It turns out that this expression actually has a rational value, which is kind of insane to think about, and here's how we find the value. The first thing to do is let x equal the expression square root of 2 plus the square root of 2 plus the square root of 2 plus the square root of 2 and so on, and then notice that the value x appears in the expression for x itself. Since there are an infinite number of square roots, if we disregard the first square root, the expression square root of 2 plus the square root of 2 plus the square root of 2 and so on after the first term still has an infinite number of square roots. This is because there are an infinite number of them, so taking one of them away still results in an infinite number of them. So we can say that this part of the expression after the first square root has the same value as x, since it's still square root of 2 plus square root of 2 plus square root of 2 and so on an infinite number of times. So if we substitute the part of the expression after the first term with x, this equation becomes x equals the square root of 2 plus x. Because notice we've just substituted the part of the expression after the first term with x. To solve for the value of x, we should first square both sides of the equation, so this becomes x squared equals 2 plus x. Since the square and the square root cancel out on the right-hand side, we can rearrange the terms in this equation and rewrite this as x squared minus x minus 2 equals 0, and this is now just a standard quadratic equation. We can factor the left-hand side as x plus 1 times x minus 2, and this is equal to 0, which means x equals negative 1 or x equals 2. X can't equal negative 1 because the original expression was an infinitely nested square root with only sums of positive terms. So the only solution that makes sense is x equals 2. Since we originally set x equals the square root of 2 plus the square root of 2 plus the square root of 2 plus the square root of 2 and so on, and x equals 2, this means the expression is equal to 2. So we had an expression that contains an infinitely many number of nested square roots, and the value turns out to be a rational number, which is definitely unexpected.